Let's use rational zeros theorem to find all the zeros of this g of x polynomial and factor it out completely. So we're going to start with grabbing our p and grabbing our q. Our p is the 4 and our q is the 2. First, we want to find the factors of 4, the p. That's positive and negative 1, positive and negative 2, and positive and negative 4. Now we need the factors of 2. Those are the q's. That is positive and negative 1 and positive and negative 2. So we have all our factors now, and we're going to try to find out what the possible rational zeros are. So that's a key term, rational. We're going to find all of the possible rational zeros we have for this function, meaning there can be irrational and imaginary zeros attached with this. This is only going to help us find the ones that are rational. So we want to list our p's over our q's in the form of a fraction. I'm going to start with the positive ones. We can try positive 1 over positive 1, which is 1. Positive 1 over negative 1, which is negative 1. Positive 1 over positive 2, which is 1/2. And positive 1 over negative 2, which is negative 1/2. So there we go. We have 4 unique options so far. And we're going to do the same thing with all of the other ones. But this time we'll do negative 1. The negative 1 is our p value we're going to choose. And again, going to run it through all 4 q values. Positive 1, which is negative 1. Negative 1 over negative 1, which is positive 1. Negative 1 over positive 2, which is negative 1/2. And negative 1 over negative 2, which is positive 1/2. So not unique. We get the same ones we got from the last one. So really, when you're testing both positive and negatives for both, you're not going to get unique solutions if you're trying them both in both iterations. So if I run through all the positive 1 numerators, it's going to match everything from the negative 1 numerators because the denominators all are testing the positive and the negative values. So I'm going to run through the 2's now. We have positive 2 over 1, which is 2. There we have another unique choice. Positive 2 over negative 1, which is negative 2. There we have another unique choice. Positive 2 over positive 2, which is 1, not unique. Positive 2 over negative 2, which is negative 1, also not unique. Now, if I run through all the negative 2 numerators, I'm going to get the same thing from these positive 2's, so I'm actually not going to write those. Now let's do the positive 4's. Positive 4 over positive 1 is 4, unique. Positive 4, oh, that is my highlighter. Let's get rid of that. Positive 4 over negative 1 is negative 4. We have another unique scenario. And then we have positive 4 over 2, which is positive 2, not unique. Positive 4 over negative 2, which is negative 2, also not unique. And again, if I run through the negative 4 numerators, it's going to get the same thing as these positive 4's because I'm running through all the negatives. So I'm not going to write those. So what do we get? We get a set of 6 unique values. I'm sorry, that's 8. That we can group together in the positive and negatives as 4 choices there. So our possible rational zeros are positive and negative 1/2, positive and negative 1, positive and negative 2, and positive and negative 4. These are our possible rational zeros. And from here, we're going to start testing them out using synthetic division. We want to choose one and see if it has a remainder or not. If it has a remainder, then it must not be a 0 because it doesn't divide it evenly. If it doesn't have a remainder, we found ourselves a 0. So let's start picking out a choice. Let's start with 1/2. Let's just start with 1/2. So we take our 1/2 and put that in the box, and we write out the coefficients of our polynomial. That is the 2x cubed, negative 7x squared, positive 4x, and positive 4. And we run through that. Bring down the 2, we get a 2. 1/2 times 2 is 1. Negative 7 plus 1 is negative 6. Negative 6 times 1/2 is negative 3. 4 minus 3 is 1. 1 times 1/2 is 1/2. And 4 plus 1/2 is 4.5, 4.5, however you want to put it, but not 0. So what does that tell us? It tells us that 1/2 is not a 0. So we can get rid of 1/2. That doesn't necessarily mean that negative 1/2 can't be a 0. It just means that the positive 1/2 is not a 0. So we choose another one. I'm going to choose positive 2 in this case. So we choose 2, again, put the coefficients of our polynomial, and the same process. Bring down the 2. 2 times 2 is 4. Negative 7 plus 4 is negative 3. Negative 3 times 2 is negative 6. 4 minus 6 is negative 2. And negative 2 times 2 is negative 4. Add those up and you get 0. So we have no remainder. What does that tell us? That tells us a few things. Let's start with what that means for the 0. We learn that 2 is a 0, which translates to x minus 2 is a factor of this polynomial. That's because we can set 2 equal to x, or x equal to 2, subtract the 2 over, and you have x minus 2 equals 0, making it a factor of this polynomial. So we learn that. And then, of course, we learn that we have a quotient 2x squared minus 3x minus 2 equals 0. So we've gotten rid of one of the factors, and now we can proceed at looking for factors for this new part. Now, if we have something with a degree higher than 2, you're going to want to check your P's and Q's for your new polynomial, run through the zero remainder theorem again, and just see what you can get. See if you can get another 0 out. But now that we have a quadratic equation, a degree of 2, we have a bunch of different methods for how to factor this. You can use quadratic formula, completing the square, factor by grouping, the diamond method, the X method, whatever it is you learned, you can use that. I'm just going to go ahead and write what this factors into. This factors into 2x plus 1 times x minus 2 equals 0, which, of course, if you set those separately equal to 0 using zero product property, you get that x equals negative 1/2 and x equals 2. So notice we get negative 1/2, like I said before. Just because 1/2 doesn't work doesn't mean negative 1/2 doesn't work. And we get 2. Just like before, we also got 2. That means that even if you get 2 as a factor for your polynomial at some step, some point, doesn't mean 2 can't be a factor again. You can definitely find it again. That's going to be dealing with the multiplicity of certain zeros. So let's round up everything we have so far. So what are our zeros? We found a 2 before. We just found another 2, and we just found negative 1/2. So that tells us that we can rewrite g of x as x minus 2 squared, because we got 2 as a 0 twice. That's multiplicity of 2. And we can you could write x plus 1/2, but that doesn't look great. So we're going to write 2x plus 1, which is the exact same binomial that we had before there. And so we have our g of x now completely factored into this nice factored equation, which is going to help us for graphing or for interpreting zeros or anything like that.